All right, and so we're going to continue working through examples now after discussing the change of variables idea for double integrals. And so we're given this problem, and in this case we're actually given the substitution to use. Sometimes we're given that, sometimes we're not, okay? So we could just go forward and do the evaluation, but we actually, a good practice is to step back and think about D and D star first, okay? So I'm going to draw a space for D star. So this is going to be for D star. I'm not going to fill it in yet. And then there's also going to be a space for D. Okay, and here's D. Now for me, D is actually the easier place to start drawing. Mainly because it's what we know. So for example, we already know that x is bounded by 0 and 2 based on the integral, and also we know that y is bounded between x over 2 plus 1 and x over 2. Okay, so that is to say, if we were to graph this, okay, so here's, let's call that 1, and here's, we'll call that 2. And so here I get, we'll call that 2. Okay, here we go. Up 1 over 1. Okay, there's one line, and there's another. Oops, there's the other line. And so we're looking at this space in here, and let me just shade it in quickly. So this is what our space in D would look like. Alright, conversely, and if you can think about this, we could really span this image by taking a vector along here and a vector along here. Okay, and that would span the image. Okay, or span this region. Alright, but then now the confusing part is I always think, okay, well, what does this new D star space look like? Well, really it is supposed to be a nice rectangle. Okay, so let's just draw a nice rectangle, i.e. a square. So something like this. Okay. And so it's going to look, we're going to change this, change that square into this, and also remember it is 1-to-1, so we would like it to be invertible. Okay, but the question is, well, if we want to generate this D star space in an easy way, so we want to pick two nice vectors. We don't quite know what these boundaries are yet, but we'll get there. Okay. Alright, so that's kind of what we're thinking. Now we want to think about the Jacobian, because yes, we can do all this transformation, but what does this even mean? Okay, so the Jacobian is a piece of that, so remembering that it's a scale factor geometrically. Okay, so if I think about this series of transformations, okay, the partial of x with respect to u is going to be 1, and then the partial of x with respect to, oh, and I'm sorry, actually, let's redo that. Okay, so again, these are given in terms of u and v. I might need to write those in terms of x and y. So the first one is actually kind of nice. This is just giving me x as u. Okay, then if I were to solve this for y, and again, using that substitution here, what I would get is that this is u plus v over 2. Okay, and now I can continue with the Jacobian. Okay, so with this new system of equations, I can take express the Jacobian as 1. Okay, so that's the partial of x with respect to u, and the partial of x with respect to v is 0 because there's no v. Okay, and then the partial of y with respect to u is 1/2, and the partial of y with respect to v is 1/2, and then I take the absolute value, or the determinant of that, sorry, and I just get 1/2. Okay, so I know the Jacobian. I can do the substitution. Okay, the only thing I haven't figured out yet is the bounds. Okay, so I'm going to leave, I'm going to leave the bounds, I'm going to leave space for the bounds and come back to those. Okay, so x to the 5th, we know, well, x we said was u, so this is going to be, let's erase that, u to the 5th, and then we're saying that 2y minus x is the same as v. Okay, and then so this will be e to the v squared, and then now we're going to have 1/2 du dv. Okay, so now the only thing I need to figure out is what are these bounds. Okay, well, if u is just x, if u is just x, then the bounds for u are going to be the same as the bounds for x, and the bounds for x are 0 to 2, so those become 0 and 2. Now the question is, what about v? Okay, and it turns out that these are also going to be, so if we think about this, this is going to be that 2 there from, so this is the u vector, and this is the v vector, okay, and this is also going to be 2 as well. Again, you could plug in kind of that upper bound and do, okay, well, we know the maximum x is 2, 2 plus 2 over 2 is 2, plus 1 is 2, okay, and then similar down there, so this is going to be 0 to 2 as well. Alright, so again, this is just by saying like you have 2 over 2 plus 1, and then for the lower bound here I did 0 over 2. Okay, so using those bounds for x instead. Okay, just some comments here. So here you were given the substitution. Sometimes they're not going to be given to you, i.e. the next video. So figuring out the substitution can be tricky, and so what we recommend is that instead of looking at the integrand, think of a substitution that will make the domain simple. And I'm not talking about simple as in like no loops and whatever like that. I'm just talking about like easy computationally. Okay, draw pictures. Okay, the picture can really tell you a lot. Okay, and then also keep in mind that you need to be able to undo the substitution should you need to. So just make sure that it is invertible. Alright, so that's another example, and then some tips on how we're going to continue to use this change of variables.